What we're going to do now is cover basic levels of measurement and review elementary statistics. This might be review for some of you who have had Psych 234 or elementary statistics course in another department. It is an important place to start because it's the building block of our most commonly used univariate and bivariate statistical tests. In the regular face-to-face semester, we have a scavenger hunt. However, since this course is online, we will hold a PowerPoint lecture format. Most times when I ask students what they remember from their elementary statistics class, they shout out 3 words: mean, median, and mode. To a certain extent, this is the only information retained from that class. Like anything else, the best way to retain information is to practice and use it often. Let's see what you remember about elementary statistics. This slide contains 4 variables, each in their own box. This tests your knowledge about levels of measurement, which is important to know before you design any survey, collect data, or run any statistical test. In general, there are 4 levels of measurement: nominal, ordinal, ratio, and interval. A variable is something that varies. Some variables have attributes or levels. You will read about this in your textbook. Some variables are independent variables, which can be an event, manipulation, or intervention that has an impact on some dependent variable. A dependent variable is the variable that is measured, the variable that is impacted by the independent variable. Let's define each level of measurement first, and then I want you to try and identify which variable is which level of measurement. A nominal level variable is a variable that is considered discrete. There is no order or value to its attributes or levels. For example, gender, male or female; religious affiliation, Democrat, Republican, Independent, Tea Party, etc. An ordinal level variable is a variable that has rank order of its attributes or levels. For example, college rank, freshman, sophomore, junior, senior. And the differences between rank are not equal distance. With a variable like this, you could say that an attribute of this variable has more or is higher than another. Senior is higher than freshman. A ratio level variable is a variable where distance between data points is equal and may have a true 0. An interval level variable is a variable where the distance between data points is equal and may not have a true 0. Give yourself a minute to identify the appropriate level of measurement for each of the variables on this slide. Then we'll discuss the right answers. Here are the correct answers. Socioeconomic status is ordinal level of measurement. SES is the variable and has 3 attributes or levels: low, middle, and high, which have a rank order. We can argue that someone with high SES has more than someone with low SES. There is no equal distance between attributes or levels. Age in years is ratio level measurement. There is equal distance between each year of age. Political affiliation is nominal level of measurement. This is a discrete variable, and we cannot give rank order nor equal distance to the assumed attributes or levels: Democrat, Republican, Independent, etc. IQ is interval level of measurement. Theoretically, we can argue that there is equal distance between IQ points. However, we cannot say that someone can have a complete absence, a true zero, of intelligence. These 4 levels of measurement are most often used in the physical sciences, not in the social sciences. It is important to know that in social science, we do not distinguish between ratio and interval levels of measurement. In fact, we combine interval and ratio into what we call scale or continuous levels of measurement. Therefore, for the purposes of this course, you must be able to identify 3 levels of measurement: nominal, ordinal, and scale or continuous. The SPSS software that you will use to complete your labs also defines the levels of measurement this way. In general, if a variable can have 0 and there are equal distance between data points, we identify that variable as scale or continuous. This is important to know. What do these 2 letters symbolize? The M, italicized, is a measure of central tendency, which represents the sample mean, the average score of a sample of participants. You can read more about this in your APA manual on pages 118 to 120. There are also 2 additional measures of central tendency: median and mode. The median, MDN, is the middlemost number in a set of scores, and the mode is the most frequently occurring score. Which is the best measure of central tendency to use? The answer is, it depends on your data. The mean is probably the most often used. However, if your data has a few outliers, for example, extreme scores, sometimes researchers report the median instead of the mean. For example, if you were studying annual salary and your salaries of 5 participants looked like this. There is one extreme score, which we would call an outlier, which is the person who made $250,000. In this case, the median would be the most representative central tendency measure to use. To calculate the mean, however, you would add all 5 scores up and then divide by 5. To obtain the median, you would order the scores from least to greatest and choose the score that was in the middle. In this case, we would report the mean as $89,000 and the median as $50,000. The letter N italicized indicates the total sample size. For example, if there were 30 students in this course, I would write N equals 30. Small n represents a distinct subsample of your total sample. For example, if the class of 30 had 10 women and 20 men, we would write You can read more about the difference between capital N and lowercase n in your APA manual, page 118. There are several statistical symbols in each box on this slide. Do any of these look familiar? Let's review. T is a test statistic for the t-test. There are 3 types of t-tests: independent samples t-test, paired samples t-test, and one sample t-test. The one sample t-test is not often used and won't be a focal point of this course. The other 2 types are important for you to know. Basically, the independent t-test looks at differences between 2 groups. The paired sample t-test is the before and after test, which looks at differences on pre and post tests with one group only. Review the handout, Levels of Measurement, Statistical Tests, for concrete examples. This stands for degrees of freedom. This is the amount that scores are free to vary once the population mean is known. You will not need to know how to calculate this by hand like you did in elementary statistics. SPSS software will do that for you. This represents your research hypothesis. This is an educated guess about the relationships between variables. Your H1 can either be directional, where you specify which way the relationship between variables move, or non-directional. You do not specify the direction of the relationship. The null hypothesis is represented by HO and states there is no relationship between variables. This is chi-square, a statistical test that looks at if what is observed is any different than what is expected, all things being equal. We will not cover this test in this course too much, as it is very hard to interpret. You can read more about this in your handout. Let's talk about R and R squared. This is a correlation coefficient representing the statistical test Pearson's R. Pearson's R tests the relationship between two scale or continuous variables. The R tells you two things: the strength of the relationship between variables and the direction of the relationship between variables. If after running your Pearson's R analysis your R is a positive number, that means the two variables move in the same direction. When one goes up, the other goes up. If there is a minus sign in front of the R, that means the two variables move in the opposite direction. When one goes up, the other goes down. The number indicated in R also tells you the strength of the relationship between variables. See the handout, levels of measurement, statistical tests for what constitutes a weak, moderate, or strong relationship. In addition, you can square the R, and that will produce an R squared, which is called the coefficient of determination. After squaring the R, move the decimal place over twice to convert it to a percentage. Converting R squared to a percentage tells you the amount of variance in one variable that accounts for the amount of variance in the other variable. In other words, R squared represents the amount of overlap between two variables. This is called the p-value, which stands for probability. In other words, this represents the risk you're willing to take to make a type 1 error. A type 1 error is when you find that there is a statistically significant difference or relationship between variables when it doesn't really exist. In other words, if your p-value is less than 0.05, this means that there is less than a 5% chance that any difference or relationship you found is due to error. This means that you can be 95% confident that any change in scores or any relationship between variables that you find was due to your intervention, event, manipulation, or any real relationship that exists in the universe. The p-value indicates your statistical significance. Most researchers set their p-values to 0.05, meaning the risk they're willing to take to make a type 1 error is 5%. F-test. F is a test statistic for the ANOVA test. F is a test statistic for the ANOVA test. ANOVA tests the difference on a dependent variable between 3 or more groups. See the handout, levels of measurement statistical tests for a specific example of ANOVA. This is a symbol for Cronbach's alpha. This is a measure of reliability of standardized scales. We'll learn more about this measure of reliability later in the semester. Okay, we covered the basics of hypotheses and what makes a hypothesis either directional or non-directional, as well as what a null hypothesis, or H sub O, is. There are 4 H1s on the slide above. Which is considered a null hypothesis? If you chose the second one from the top, you are correct. Remember, the null states that there is no relationship between variables. Which H1 is considered directional? If you chose the last H1, you are correct. This answer is correct because H1 specifies the direction of the relationship. Note the keyword positive impact that specifies which way their quality of life will go, better, higher, etc. Look at this comic. What is the issue that limits the generalizability of the study findings on exercise? If you answered sampling, you are correct. We can assume the researcher stood outside of a gym to gather his data, which is not a representative sample of the population. Therefore, this lowers the generalizability of the study's findings. Review the handout, Levels of Measurement Statistical Tests. What statistical test would you use to answer this question? If you answered one sample t-test, you are correct. However, the one sample t-test is not a focus of this course, as it compares a sample mean to a population mean that is known. What statistical test would you use to answer this question? If you answered chi-square, you were correct. This test examines if what was observed is significantly different from what was expected by chance, if all other things are equal. What statistical test would you use to answer this question? If you answered independent samples t-test, you are correct. This test is appropriate because you are comparing two different groups on one dependent variable, salary, and that dependent variable is a scale or continuous level of measurement. The independent variable is master's degree with 2 attributes or levels, social work and psychology. What statistical test would you use to answer this question? If you answered paired samples t-test, you are correct. This test is appropriate because you are comparing scores before and after an intervention with one group of kids, not two separate groups of kids. The dependent variable is attitudes and knowledge of drugs, which would probably be measured by a standardized scale, assuming that scale would be a scale or continuous level of measurement. Okay, let's test your knowledge of variables and levels of measurement to see how much you've learned. On the following slides, identify what are the levels of measurement for each variable based on the way the question or item is designed or phrased. Remember, a variable in itself is not always a specific level of measurement. It all depends on how you ask the question. For example, let's take the variable weight. If I phrase the question like this on a survey of amateur boxers, how much do you weigh in pounds? The participant can write the number of pounds he or she weighs in the line next to the question. This would be a scale or continuous level of measurement. However, if I phrase the question like this, what is your weight class? Check 1. Superfly featherweight, featherweight, middleweight. That means the way I phrase the attributes, superfly, feather, or middle, has a rank order. Middle is more than superfly, for example. Therefore, this way would be worded as an ordinal level of measurement. Let's practice on the following slides. Which level of measurement is this variable? The answer is scale or continuous. Although not likely, someone might have 0% body fat. We can also say that there is equal distance between 5 and 10% body fat and 25 to 30% body fat. Which level of measurement is this variable? The answer is ordinal. We can argue that each attribute is higher than the one before it. Which level of measurement is this variable? The answer is nominal. All political jokes aside, there is no rank order between these attributes. Which level of measurement is this variable? The answer is scale or continuous. A participant might indicate 0 years of education, and there are equal distance between years. Which level of measurement is this variable? The answer is ordinal. Again, there is a rank order to these attributes, as each option or attribute is higher than the one before it. Which level of measurement is this variable? The answer is nominal. We are not asking how much washing, and there is no rank order to these chores. Which level of measurement is this variable? The answer is scale or continuous. Which level of measurement is this variable? The answer is scale or continuous. Which level of measurement is this variable? The answer is ordinal. Which level of measurement is this variable? The answer is ordinal. Okay, now that you have reviewed levels of measurement, let's talk about what operationalizing variables means. You will read more about this in your textbook. Operationalization means that you provide an operational definition for your variables. Some variables, most in fact, are what we call abstract or constructs. In other words, if you cannot see it or hold it in your hand, we consider it to be abstract. Some examples would include faith, attitude, depression, happiness. In order to measure these kinds of things, we need to operationalize them. We must define its concrete form by defining how we're going to measure or capture the construct. In the above research question, there are two variables of interest to measure: aggressive behavior and academic achievement. How might you operationalize aggression so that we can measure it? How might you operationalize academic achievement so we could measure that as well? We might operationalize aggression as the number of times per hour that a teen kicks another teen. We might operationalize academic achievement as grade point average, or GPA, on a 4.0 scale. There are lots of ways to operationalize variables. It's up to you as the researcher to identify your variables of interest, identify how you will operationalize those variables, and then identify each variable's level of measurement. You cannot run statistical analysis to test your H1 without this information. This concludes the lecture on levels of measurement and review of basic statistics. Please be sure to stop by my office or email with any questions about the content of this lecture.